Imagine a tomato plant at the very edge of your backyard garden. Its once vibrant leaves have faded to the brittle color of aged paper, and its stems sag heavily toward the parched earth, as if giving up on the season entirely. The delicate flowers that promised a bountiful harvest only a week ago have curled shut, seemingly for good. Most home gardeners would see this as a finality, reaching for a shovel to clear the space and tossing the remains onto a compost heap, believing there was nothing more to be done. However, soil scientists who study the precise physiology of plant decay have uncovered a reality that flips the script. In the vast majority of cases, the plant isn't actually dead. It is merely starving. It is suffering from a critical depletion of specific nutrients that the soil can no longer supply. Remarkably, these life-saving elements can be restored in as little as 48 hours using simple ingredients found in the average American kitchen. Today, we explore 5 zero-cost liquid fertilizers used by generations of traditional farmers, but overlooked by an industry that cannot profit from a discarded peel. We will dive into the science of these rescues and reveal the one mistake that prevents them from working. Before we begin, I'd love to hear from you. Where are you watching this video from? And what time is it right now? Leave a comment below. I can't wait to see your answers. Here is a question worth asking before another onion skin gets dropped into the trash. Which part of the onion holds more potassium? Most people assume it is the white, juicy bulb that goes into our soups and stir-fries. However, the answer is surprising. It is the dry, papery brown skin that we peel off and throw away. For as long as kitchens have existed, these outer layers, considered garbage by modern standards, carry one of the most concentrated doses of potassium, calcium, magnesium, and iron found anywhere in the produce aisle. Beyond minerals, onion skins are rich in a powerful antioxidant called quercetin. This is the same compound that makes red wine, apples, and blueberries beneficial for human heart health. Inside a plant, quercetin performs similar protective work. It acts as a biological shield, protecting leaves from the harsh summer sun and slowing the spread of fungal infections. It steadies the plant's internal chemistry when a sudden heat wave or a cold snap rolls through, acting much like an immune booster for the vegetable garden. The common mistake: burial versus extraction. This is where many well-meaning gardeners make a wrong turn. They hear about the benefits of onion peels and imagine that digging the skins directly into the soil will feed the roots. While this method technically works, it takes weeks for the tough, fibrous skins to decompose. While the skins sit in the dirt, the plant above continues to wilt. By the time the nutrients are released, the plant might already be gone. The real secret lies in water extraction. Think of it like a tea bag. Water pulls the essential compounds out of the plant tissue far more efficiently than soil microbes can break them down. To create this golden elixir, all you need is a handful of dry skins and a quart jar of cool tap water. Within 24 hours, the water darkens to a pale tea color. By 48 hours, it becomes a deep, rich amber. That color change is the visual proof that the potassium, magnesium, and quercetin have dissolved into the liquid. Once these minerals are in the water, they are in a form the plant can absorb through its roots immediately. No composting, no waiting, and no complex breakdown required. When poured at the base of a yellowing tomato plant or a pepper that has stopped setting fruit, this amber liquid begins to work within days. You will notice the stems thickening, new leaves coming in a deeper shade of green, and flower production picking up within a week. It is a professional-grade rescue for the price of a kitchen scrap. What if the cloudy water you pour down the drain every evening, the leftover liquid from rinsing a pot of uncooked rice, turns out to be one of the most powerful soil treatments ever studied? Under a microscope, this claim sounds like an exaggeration, but it is a scientific reality. Fresh from the pot, washed rice water carries starches, B vitamins, and small amounts of iron and zinc. While this is mildly useful to a garden, the real transformation begins a few days later, after the water has been left to sit at room temperature in a covered jar. As the liquid ages, it takes on a faintly sour, tangy smell, similar to a sourdough starter. For most people, this smell would be a signal to throw it out. However, for a gardener, this scent is the signature of a microbial bloom. Lactic acid bacteria and wild yeasts have moved in and taken over the liquid, turning a simple waste product into a biological powerhouse. This process is deeply rooted in the research of Dr. Teruo Higa, a Japanese agricultural scientist who, in the 1980s, introduced the concept of effective microorganisms, EM. His work showed that certain beneficial microbes, when added to depleted soil, could bring it back to life. in weeks. The microbes at the heart of those expensive global formulas are the same ones that appear naturally in your fermented rice water for free. When this liquid is applied to a garden bed, something remarkable happens underground. The bacteria and yeasts in the water meet the microbes already living around the plant roots. The starches in the rice water act as a massive feast, causing the soil microbiome to wake up and multiply. Within a single week, the population of beneficial microbes around a treated plant can triple. To put this in perspective, 1 teaspoon of healthy soil after this treatment can hold more than 1 billion living organisms, a population larger than that of North America, packed into a volume smaller than a coffee bean. The genius of rice water is that it does not just feed the plant. It builds the plant's support system. It is the difference between handing someone a single meal and handing them a fully functioning kitchen. A single meal runs out, but a kitchen keeps producing. The single biggest mistake first-time users make is pouring the rice water on fresh. Fresh rice water is too mild to create a dramatic result. It must ferment for 3 to 5 days until that sour tang is present. Furthermore, you must follow the dilution rule. Fermented rice water should be mixed with plain water at a 1:10 ratio. Undiluted, the acidity is strong enough to irritate tender roots. Correctly diluted, it is gentle enough to apply every week, creating a thriving ecosystem that sustains your plants through the toughest growing seasons. Every refrigerator in America has one. The forgotten tomato at the bottom of the crisper drawer, the head of lettuce that wilted before anyone could use it, or the bruised cucumber pushed to the back of the shelf. For most households, these scraps end up in the trash, or, at best, in a compost bin that won't produce usable material for another 6 months. However, for a gardener who understands the science of digestate, these same scraps are the fastest acting nitrogen source that can be manufactured at home. The science behind this method dates back to the 1840s and a German chemist named Justus von Liebig, one of the founding fathers of modern agriculture. Liebig proved something that fundamentally changed how we think about plant growth, known as the law of the minimum. He used the analogy of a wooden barrel with staves of different heights. The water inside the barrel can only rise as high as the shortest stave. It doesn't matter how tall the rest of the staves are. The shortest one caps the capacity of the whole barrel. Plants work the same way. If a tomato plant has plenty of potassium and phosphorus, but lacks nitrogen, its growth stops at the nitrogen line. In the average backyard garden, nitrogen is almost always the shortest stave. Green kitchen scraps, overripe tomatoes, soft peppers, wilted spinach, and bruised kale possess what soil scientists call a low carbon to nitrogen ratio. In plain language, they are packed with nitrogen compared to their fiber content. When these scraps are crushed into a 5-gallon bucket covered with water and weighted down to stay submerged for about 2 weeks, a process called nitrogen mineralization occurs. Bacteria in the water break the plant cells apart, releasing the locked nitrogen directly into the liquid. This happens far faster in water than it ever would in a traditional compost pile. The finished liquid is not pretty. It is dark, cloudy, and carries a pungent, earthy smell. That smell is the proof that the mineralization is complete. However, this is also where many gardeners make a fatal mistake. Because this liquid is so potent, applying it undiluted or as a foliar spray onto the leaves is a disaster. The nitrogen concentration is high enough to scorch leaves on contact and can burn delicate root hairs beyond recovery. To use this liquid gold safely, it must be diluted at a ratio of 1 part scrap liquid to 30 parts fresh water. Applied directly to the soil at the base of the plant, the results are visible within 4 to 6 days. Pale, tired leaves deepen to full shades of green, and new shoots begin to push out from leaf axils where none were forming before. By redirecting this waste stream, you stop needing to buy commercial nitrogen altogether. If a struggling plant is missing not just 1, but 5 or 6 nutrients simultaneously, a single ingredient remedy will not suffice. For these complex cases, the garden needs a full spectrum formula, a mixture built from items most households throw away before breakfast. Understanding the synergy of these ingredients is the difference between a half-working tonic and a liquid that can save a plant overnight. This formula begins with 3 familiar staples. Banana peels provide an immediate boost of potassium, the mineral that drives flowering, fruiting, and the plant's ability to regulate water. A tomato plant short on potassium produces small, watery fruits with skins that split as they ripen. Next, finely crushed eggshells deliver calcium carbonate, the essential building block of cell walls. Calcium deficiency is the hidden culprit behind blossom and rot, that frustrating black, sunken patch at the bottom of an otherwise perfect tomato. Finally, used coffee grounds contribute a slow-release source of nitrogen while improving soil texture. It is worth pausing here to debunk a common gardening myth. Used coffee grounds do not make your soil highly acidic. While fresh, unbrewed grounds are acidic, university soil labs have measured used grounds at a pH of 6.5 to 6.8, which is nearly neutral and exactly where most vegetables prefer to grow. To take this recipe from good to exceptional, we add 2 specialty ingredients. The first is Epsom salt, magnesium sulfate. Magnesium sits at the exact center of every chlorophyll molecule. Without it, photosynthesis stops. If your leaves are yellowing between the veins, while the veins themselves stay green, a pattern known as interveinal chlorosis, Epsom salt is the cure. The final, and perhaps most important ingredient, is blackstrap molasses. Unlike regular table syrup, blackstrap molasses is a dense source of iron and trace minerals. However, its primary role is serving as a microbial dinner bell. Adding a single tablespoon of molasses to your brew causes the populations of beneficial bacteria to multiply within hours. These hyperactive microbes break down the banana peels and eggshells far faster than they would decompose naturally. Combine your peels, crushed shells, used grounds, a tablespoon of Epsom salt, and a tablespoon of molasses into a gallon of warm water. Let this mixture steep in a covered bucket for 3 to 5 days. The common mistake here is skipping the molasses. Without this catalyst, the nutrients remain locked in the organic matter for weeks. With it, you create a live culture, full-spectrum rescue tonic that provides potassium, calcium, nitrogen, magnesium, and iron in a single, powerful pour. Before 1913, the concept of synthetic fertilizer simply did not exist. Every farm on Earth, from the American Midwest to the foothills of the Himalayas, operated on 2 primary inputs: animal manure and compost. This changed when German chemists Fritz Haber and Karl Bosch developed a process to pull nitrogen out of thin air and convert it into ammonia. While the Haber-Bosch process is credited with feeding billions of people, it also introduced a hidden trade-off. It taught us to feed the plant while starving the soil. For the home gardener, the old method, specifically manure tea, remains a superior way to rescue a dying plant, because it restores the soil's biological health along with its chemistry. The process is as simple as its name suggests. A shovelful of aged, dried manure is placed into a porous sack. An old cotton pillowcase, a burlap bag, or even a mesh laundry bag works perfectly. This giant tea bag is tied shut and submerged in a 5-gallon bucket of water. Over the next 3 to 5 days, the water extracts the soluble nitrogen, phosphorus, potassium, and trace minerals, leaving the solid matter and weed seeds safely inside the sack. The type of manure you choose dictates the results you will see in the garden. Aged chicken manure carries the highest levels of nitrogen and phosphorus, making it a powerful growth stimulant that can push a tired tomato plant back into heavy flowering within a week. Cow manure is more balanced and exceptional for building the long-term humus layer of the soil. Rabbit manure is the quiet secret of master gardeners. It is a cold manure, meaning its nitrogen is in such a mild form that it is the safest option for young, tender seedlings. The single most dangerous mistake in this method is using fresh manure. Raw droppings carry high levels of ammonia that can scorch roots instantly, along with pathogens and undigested weed seeds. Manure must be aged for at least 6 months to a year before it ever touches the water. Once brewed, the tea must be diluted until it reaches the color of weak iced tea, roughly a 1 to 10 ratio with clean water. We have journeyed through 5 powerful liquid elixirs: the onion peel elixir, fermented rice water, vegetable scrap digestate, the kitchen cocktail, and aged manure tea. Each of these solutions addresses a specific deficiency, costs absolutely nothing, and begins to show visible results within days, sometimes even hours. What truly binds these methods together is the principle of the closed loop. In our modern world, we have been conditioned to view kitchen scraps as waste to be hauled away. But to a starving garden, these are the most valuable inputs available. The gardener who understands this shift in perspective gains more than just healthy tomatoes. They gain independence from the industrial fertilizer cycle. You don't need a patented formula or a premium brand to grow a thriving garden. You simply need to pay attention to what the soil is asking for. The next time a zucchini fades or a pepper plant stops producing, Do not be so quick to reach for the shovel. The remedy is almost certainly already in your home, waiting to be unlocked. If any of these 5 methods resonated with you, leave a note below about which one you plan to try first. Share this with a fellow gardener who might be on the verge of giving up on a struggling plant. Let's preserve this old knowledge and turn our waste back into life. Happy gardening!